Transformations of exponential functions. Now, we've dealt with transformations before. We've seen horizontal translations or horizontal shifts, moving things along the x-axis to the left or to the right. We've seen vertical shifts or vertical translations. We've seen reflections or flips, and then compressions and stretches. And we got the same things that happen with our exponential functions. So if I look at this, may be a little bit hard to see. But that function equation right there, f of x equals a times b raised to the, where b is raised to the power of x minus h, and then plus k. And we see something similar here to this y equals 2 raised to the power of x plus 3 minus 5. Now first, let's think about this x plus 3 as being like in a grouping, because it is. It's up here in this exponent, just like it would be in a parentheses if we were dealing with a quadratic or a polynomial function. And of course, we know that our horizontal transformations or translations are a little bit counterintuitive because it's based on this x minus h. And of course, if I put a positive number in for h, then it becomes negative. Or if I put a negative number in for h, it becomes positive. And that's where the counterintuitive comes in. And such that if I see in this example where we got x plus 3, while I might initially think that plus 3 is going to move this horizontally to the right, well, in fact, it doesn't, because it moves it to the left. And that's really because that would be x minus negative 3, which of course then becomes positive 3. So we're going to see a horizontal translation to the left, and then this negative 5 is going to push it down. We're going to have a vertical shift down by 5. Now let's go back to thinking about our parent function. And we're going to graph these quickly here in a moment. So I should see a horizontal translation to the left by 3. We should see it go down vertically by negative 5, but down 5 units. Now in our parent function, we hovered along the x-axis and then boom, went up with a y-intercept at where x is 0, y is equal to 1. What's going to happen here is obviously this negative 5, we're going to push it down. Now let's think about the domain first. Is there anything that's going to restrict our domain? I'm not dividing by 0. I'm not taking the square root of the negative number. I don't have any domain issues. So my domain really is going to be negative infinity out to infinity, or all real numbers. Now the range of our parent function, if you recall, was y had to be greater than 0. But what about when we're pushing that down 5 units? What would our range be then? Before we see it on the graph, let's just think about it. Well, I think my range then is going to be y such that y must be greater than negative 5. Out to infinity. And then this horizontal transformation in the x plus 3, you know what, I think it's going to affect my y-intercept. And I think my y-intercept now is just going to equal 3 rather than 1. All right, we're going to take a look at that on the graph in a moment. Now, let's look at this second equation. Y equals 0.1 times 6 raised to the power of x minus 3. Well, again, real quick, I can see that I've got a vertical shift down 3 units. That's going to affect my range. Range is now going to need to be greater than negative 3. But this 0.1, well, that's like this a, y equals a, b, x raised to the power of x minus x, plus k. And I see that 0.1 it's greater than 0, so it's not going to reflect it, but it's less than 1. And I can see right here in these properties that should compress this function vertically. In other words, like I'm pushing down on that arm particularly that arm headed up. So let's go and let's graph this and see if this bears out what we should say. Since it's just, before I leave though, as far as my y-intercept, since that's just 6 raised to the power of x, there's no horizontal translation in that, I still expect my y-intercept to be there at 1. We'll see. We're going to go graph them. All right, we're here back at our graphing calculator. And since I just actually worked with some exponential functions, I'm pretty sure my window settings are going to be okay. My stat plot, I've already turned it off a moment ago. Maybe things that I want to be checking on as I go through this. So I feel pretty good that since I did it just a little while ago, actually, in my case, I did, because I'm recording the previous video and this video on the same day. So I'm going to go in here to y equals, and we're going to change this from 4 raised to the power of x. So I can see what I did last. To y equals 2 caret x plus 3. That's going to give me my horizontal transformation. It's going to move it 3 units to the left. And then we got negative 5. And let's go take a look at our graph of this. Boom. Okay. Well, sure enough, where my parent function hovered right along the negative part of the x-axis until it took off, I can see that we've actually moved down 5 units. I count this down 1, 2, 3, 4, 5. So I got an asymptote right here at negative 5. And I can also see that I really start to begin my move up when x is equal to negative 3. We've pushed that to the left by 3 units. And then guess what? Look where my y-intercept is. It's right there at 3, where in the parent function, it's at 1. And, well, let's just take a quick look at the table just for fun. Let's see when x is equal to negative 5, y is equal to negative 4.75. Let's go down. Let's look and see what's happening as we get more and more negative. See if we're ever reaching 5. See, I keep getting closer and closer to negative 5. I keep getting closer and closer. At 14, it says it's negative 5, and then it stays there. All right, so my range then could be greater than or equal to negative 5. I think I said just greater than a moment ago. Let me check that. Make sure I got that correct. Don't want to tell you wrong. All right, greater than negative 5. I think it's just so close. All right, let's graph the other one. Now that second function was 0.1. So I'm gonna just put 0.1. A little bit lazy, didn't want to put the 0 in front of it. But I am going to put my 6 in parentheses because I want to make sure that it's not going to multiply that 0.1 to the 6 before I raise it to the power of x. And then I think we had a vertical shift down 3, if I'm not mistaken. Yeah. And let's take a look at that graph. So now again, what happened to my, is there anything that's restricting my domain? No, I can go from negative infinity out to infinity. What about my range? Well, my range is there, it's got to be greater than negative 3. I can see that right here, negative 3. And it compressed it, it pushed it down, pushed that entire graph down. In fact, let's graph the parent function, just see how it compares. We'll put that in y2, which would just be 6 raised to the power of x, if I put it in its parent form. Let's compare the two graphs. Okay. So I see that it has pushed it down, it has compressed it, not only with that vertical shift, but look at this arm right here. We're not taking off quite as fast. Let's go take a look at our graph, our table too. I want to see what's happening when it's 0. When x is 0, thinking about my y-intercept, y2 is sitting there at negative. Let me see. At y2, my parent function, I got a y-intercept at 1. But you can see when in that y1, my transformation, I get close to negative 3 on a y-intercept, but it's actually negative 2.9. And I guess algebraically we could figure that out. All right, well, there we go. We've seen some transformations. Think about that exponent. If we see anything funny looking up there, we're seeing a horizontal. If it's not in the exponent, it's negative or positive. We got a vertical shift down. If we got a coefficient in front of our base, then we could see a reflection if it's negative, which we did not see in our case. If it is greater than 1, that coefficient, in other words, like 2 times 6 raised to the power of x, it's going to stretch it vertically. If it's between 0 and 1, it's going to compress it vertically. And that's the effects of our transformations. Shazam!